Okay. So glad to see everyone. How's everybody doing? So this is Desmos. So I've given you a chance to kind of interact as a student, but I want to keep you engaged in a way that also that I can too create something like this. So Desmos is open source. So what that means is it's like, yes, it's free, but it's also, there's no premium level. So you're given like 100% premium from the start. So it's very capable and can outperform, I think, a lot of other platforms that cost school districts, cost subscriptions, that sort of thing. So that's just my personal take, but I think that it's something worthwhile to think about. So there's no real hidden features. You can create whatever you want. All right, so what you see on the screen here is the teacher view. There's also, you can switch to the student view. So if you need to tell the student what they should be doing. So right now, I think you all figured it out. I've asked you to do this little robot animation. Tell me how you're doing. You're doing okay. That's the green. You're feeling kind of in the middle, the yellow. Not doing so great, and that's the red. And if you'd like to say any more, please do so. Yeah. So then here is just the look at what we're going to be covering tonight. And my goal is for you to kind of interact as a student, but think about how you can really take this and use it for a CS Ed Week activity, for a classroom learning, maybe even like a Friday night game night with your friends. Anything's possible. So my name is David Guy. I teach math and computer science at Maynard Jackson, which is in Atlanta Public Schools. This is my second year teaching, and also my second year with support from the Constellations Center. So I teach algebra. So that's what kind of gave me the Desmos background. Was this is a math platform. So you may be thinking like, I don't know, there's not a lot of computer science that could be used. Well, it's programmed in JavaScript. So, it's very computer science friendly on a user standpoint when it comes to using it as a teacher. And we'll get into that in a little bit. So this is the welcome. Let's get to know each other. So I want you guys to share with each other. I guess I didn't ask your names, but you can share your names. How do you approach computer science? How many years have you been doing it, and where do you live, etc.? So I can see here on the teacher what people have been saying. So Mark is teaching math and computer science since the last century. Wow. As you can see, I'm seeing people type live. So this is highly interactive with your students. I mean, everything is pretty much live. Oh, hello, Yolanda. I'm glad you're here. Thank you. Yes, physical. Take it and apply it into the real world. Hello, Kelly. Las Vegas. Okay, Oregon. Cool. So as you can see, I mean, this is a screen that you as students should be able to see each other's responses when you've clicked submit. You might not be able to see them right now, but once you've clicked submit, you should be able to see everyone's responses. And as a teacher, you can kind of moderate where everyone is. So again, I wanted to kind of show you the features. Everything is pretty much live. You can see where everyone's at. I can actually hover over where people are, show their name. Now I can paste it. What I've done here is I've pasted it, so I've stopped people from going past slide 3. You'll see why. And then I can anonymize if I wanted to. So I can actually just create completely made up names, and it allows for, if there's ever like a situation you want to really challenge students, they may feel self-conscious, you can change their name. But I think for tonight's activity, we'll keep everyone's names their real names. Okay, so anyone having issues joining? Is the chat still? All right, so chat's got my link, so I think everyone's been able to join. Please let me know if there is any issue joining the Desmos, because that's where we're really going to be interacting with this. So I want to open up the next slide, and what this is a real kind of test of your dedication. You know, Georgia Tech is an important institution for providing higher ed in the state of Georgia, but we all know that sports are real big in the Southeast region for the ACC conference. So what I've given you are the 5 golds among ACC teams. And if you're really a person that can support Georgia Tech, I think you should be able to pick out which of these is the right gold. Now, of course, I'm kidding. They look so close, but just give me your best guess of what you think is the correct Georgia Tech gold. Click the submit, and then tell me how confident you are. So we're on slide 8 or slide 4, and you're picking out among, you just click over the square that you think is the Georgia Tech gold. And just let you know, the other 4 are the rivals among the ACC teams. So you don't want to get this wrong. Okay. Looks like we have just about everyone's answers in. So I will now move us to the next slide. You now should be able to see how everyone fared on this assignment. So looks like most of us think that Notre Dame's gold is the Georgia. So so this is a histogram that Desmos has created based entirely off of your response from the prior slide. So it's gathering information that you can kind of cross-reference among slides and create a graph, a chart. So you're welcome to, I'm going to share this at the end, but you can take this and turn this into a lot of interesting things for your students, how to talk about data, information, visualizing it. So we're seeing that Notre Dame gold is really attractive. Okay, so a redemption. So I want to give you a redemption opportunity to, you know, and see what you've learned. So I now have the answer to I have the color associated with the school. So now's your chance to click on the Georgia Tech gold and click submit. So we're on slide 6. And this is a redemption question. So you're offered the same question, but now I've given you a bit of a hint on which one is the Georgia Tech color. Now, did anyone purposely select the wrong answer and submit and see what happened? We got any Boston College fans? Florida State? Maybe we're mostly Notre Dame fans. So let's say I click Notre Dame. Now Desmos allows you to program it to where you can actually give the student immediate feedback. And you could give them an opportunity to try it again and again until they get the answer right. So maybe this, you know, feel like they can get to the right answer eventually. And maybe you have a way for them to respond that says, you know, why do you think, you know, why did you pick the first or second answer you chose? So just giving you this opportunity for, you know, redemption on our Georgia Tech colors. So we can see these are very close golds. You know, Notre Dame is more of a yellow. So what is going on here? So if we move to the next slide, what this is in any real digital color scheme, there's a code behind it. It's referencing to develop the pixel in your screen that is hopefully the same thing that's printed on the uniforms, the helmets, on the banners, on the diplomas, on the Georgia Tech seal. So there's this very particular color, and it's got this code here with these letters and numbers, and what this is hex. So bear with me if you're familiar with hex and you know all this already. Just, you know, let's treat it like a CS Ed week situation. So the hex code is made up of red, green, and blue. And if you know anything about electronics, screens and electronics create color through red, green, and blue. Now, I know there was a TV that came out like a while back that had a yellow, but I don't think that really took off because you really don't need an extra. Red, green, and blue will create all colors can distinguish. So what I want to do now is just to split these up into the red, green, and blue from our hex code. So you're going to type in here first, whoops, just B3, I can't type in. So, all right. It's not like this. So unfortunately, this is a math formula. So I guess I thought I'd figure this out. So there you go. So sometimes you got to worry about mathematically, you know, B is considered like a variable. So there's B3, A3, and 6-9. I'm really not trying to type it in the subscript. So that's just something that Desmos has built in. So I'll show you in a bit how to change that to text. But for our lesson right now, I'm just thinking, all right, let's split these up into the red, the green, and the blue. So let's see how we're doing with that. Okay, thank you, Mark, Amber, Lakeisha. So I'm just asking you to take the leftmost digits, B3, that's my red quantity. A3, the middle two digits, that is my green quantity, and the rightmost digits, the 6-9, is my blue quantity. So write those three separately, green and blue. Thank you. So what I really like about Desmos is that it's very interactive with the student live. So you can actually kind of see them typing things in. So if there is if there's something that they're missing, you can see them typing in something incorrectly. You can really kind of address it at that very moment. All right. So we'll go to the next page, the next slide. And I am going to break this down as simply as I can, and I don't want to get too wrapped up in, you know, how this number system is played out past 2 digits. So as you can see, I've kind of drawn the information we just put into this box into this table up here. And red, green, blue amount, this is going to be like a regular number decimal that we're used to. And so this is kind of just something that we can look and see as a quantity of red, as a quantity of green, and a quantity of blue, what 3 amounts put in that Georgia Tech gold. So the first thing we'll do is we'll fill out this table from a decimal system to a hexadecimal. Here are simple. You just type the same number you see above you. You just type the same numbers, because from 0 to 9, we can use the same number system. And we can see that those are the same numbers here. We have a 3, we have a 6, we have a 9. But once we hit 10, what hexadecimal needs is a single character to represent the number 10, a single character to represent 11, so on and so forth until 15. And whoever came up with this, sorry I don't have the history, maybe someone else does, used the first 6 letters of the alphabet instead of the quantity 10, 11, 12, and 13, 14, 15, sorry. So let's use cap. A, B, C, D, E, F. Okay. So what that just means is that wherever you see a letter, it's now represented by an idea of a quantity of a number. So this B here is actually an 11. This A is actually a 10. Now, it doesn't really mean this is 113 or this is 103. That's not what it is. And I'm sorry, I wish it were that simple, but it's not. But again, we're only going to have 2 numbers because we just have 2 digits. So the first thing I want you to do is to look at this red. And I've brought the table down here. I have 3 tables, red, green, and blue. Let's just look at the red. The hex digit is the same as up here. I'm going to draw it straight up from our red amount from the Georgia Tech gold. So B3. I'm going to type that in just digit at a time. I'm going to call it a digit even though it looks like a letter. So I have a B and my 3. Now, I have here this 16 to the first, 16 to the 0. Now, my math people out there, if you chat, the 0 power. That's right, it's 1. And actually, I can test it out right here. I can type it in. This is actually a calculator inside each one of these tables. So 16 to the 0 is 1. I want to take the row above and multiply it by the row below. So 3 times 1. You can type it in your keyboard, or there's this little keyboard icon you can click on. It won't let. If I click on this keyboard icon, I can actually type calculate. So I have 3 times 1. Now, I can't type in B times 16. Oh, I forgot to ask, what's 16 to the first power? Good. All right. So what I'm doing here is taking the digit quantity, which isn't B. What should our brain translate B into? B should be what amount? 11, right. So I want to do 16 times 11. I'm multiplying the quantity of the hex digit by its base amount, by its decimal amount. So I have these 2 numbers here, 176 and 3. 176 and 3. To find my RGB amount, I want to add those together. You're welcome to type it in. You can do it in your head. These inputs are actually calculators. You can type in a mathematical formula and it'll solve for you. All right, so who thinks they can walk me through how to find the green? Who would like to speak or chat to tell me how to find the green RGB amount? Or are we totally confused? Anyone willing to try? Well, let me just look and see what y'all got. Oh, well, you guys are already doing a lot of this. Okay, you've already figured it out. Oops. So this is another feature. If I click on, what I did is I clicked on teacher, and it brings up everyone's responses kind of in a summary. And I wanted to see, okay, how are we doing on the green? And I can see that a lot of people have already done it. Oh, thank you, Megan. Yes. So the same thing, pull down A and 3. So I'll bring up yours. So you brought down, you have A3 up here. A and 3, separate them out. Multiply A by 16, which is 10 times 16, 160. 3 times, that's 1. 16 to the 0 is 1, so it's 163. I'll give you a chance to kind of play around with this. Make sure at the end you pull back to the top and fill out the final red, green, and blue. All right, just a couple more minutes. And I want us to practice see how we're doing with this. So you're taking the hex digit, which I've given you the 3 up here, B3, A3, 69. And then use this table to split the hex digit into its 2 parts. Multiply the top row by the first row by the second row, and then add those 2 columns together. All right, so if you're feeling good, I'll go to slide. It's a matching card sort, meaning you're going to take the color, the pixel, match it with the hex code, and then if you think you got it right, go to slide 10. There's a check to see if you're right button. Click that. If it says try again, it'll tell you how many you got right. So you're going to be matching the colors with the hex codes. They help to line them up. And all you have to do is hover them over each other and they should match up. Okay, so you get some immediate feedback. Again, this is kind of hands-off. Your students can go back and forth and get it until they get it all right. So I like this feature. It's a good place to just kind of stop to check to see, do people understand? Now, I might be throwing you a curveball because you see a bunch of Fs. F mean? Well, don't think about the quantity. Think about where the other places is zeroed out. Remaining color that has a quantity, and maybe that'll help you figure out this card sort. Woo. All right, good. Right, so you can see the pattern that when you're zeroing out the green and blue, what remains? It's the red. So the FF at the start is the two reds, the two red digits. So the zeros are the green and blue. If there's no green or no blue, what remains? Red. There's no blue, there's no red. That middle two Fs, that's the green. So that's kind of a good starting point, red, green, and blue. And then our Georgia Tech gold. So let me, if you, I'm not sure if people have joined, if without seeing the session here, I'm sorry, if you're joining late, the link is in the chat. You can click on that and join live on our Desmos. Okay, so now that we are whiz-bang with the card sort, and does anyone need any help with that? So that's just something you can create. You just populate it with, here's the information, here's another piece of information. You get to quickly tell the program what is the right combination. Okay, so what I have now given you is a link. So we're going to jump out of Desmos, but we're going to come back in a little bit. So click this link on slide 11, and this is a code.org, basically a pixel creator. So, and you may see different parameters. It may ask you to sign in. You don't have to really sign into a particular class. I just want you to be able to get to this color pixelation tutorial. And the parameters are, you're going to put a 1 for the image width, 1 for the image height, and bits per pixel should be 24. There's some math behind that, and maybe you feel like you want to explain that to your students, but there are 24 bits per pixel because there's 8 bits per color, and we have 3 colors. So as you see, I've written in my code for the Georgia Tech Gold. And what I want you now to do is just type in a hex code, see what color is really kind of pulling towards you. This is just free form. And then in the next slide, upload your image, and you're going to have to save it to your hard drive. And then here it says add item. That's where you're going to click add item. So to go through that process again, there was a link on slide 11. There's an image that you should try and match up with. There's 1 pixel high, 1 pixel wide, 24 bits per pixel, and then change it to a hexadecimal number system on your code. Create a pixel of any color you want and give it a name. So if you want to add your image, you got to push the plus sign, image. And then if you want to change your color name, you just type over what's written there already. So color. Maybe it's a random hex number that you like. All right. So upload your pixel here, and we can look and see everyone's color scheme. So and give it a name. This is your creative artistic side. Thank you, Megan. Thank you, Amber. Does anyone have any issues uploading? So again, the other thing is just click add item, upload image. It's not exactly clear. This is one of those things in Desmos. You kind of have to work with what you got. This is a graphing calculator I'm in, but I'm making it into an image uploader. Well, we only have 10 more minutes, and what I'm going to do is open up the rest of the slideshow, and there's a couple tools that can be useful when it comes to finding colors. There's an actual extension on Chrome. I'll show it right here. It's called this color picker, and you just click on it, and wherever you hover your mouse, I don't know if you can see down here in the bottom right-hand corner, wherever you hover your mouse, it's going to give you the hex code and RGB. So maybe you want to paint your room the Desmos blue. you click on it, and then it saves it up here. And if you look up a hex code, you can translate it. The painting industry doesn't use hex. They use the exact same quantity to create a paint. You can actually go to your paint store with, it's not called a hex code. It's like a PMP code. I'm sorry, I'm not familiar with the exact code, but there's a way to get your paint store to create the exact color you want from a hex code. So I've got some tools for kind of finding. This one here is, you can see like on a picture, you can upload whatever image you want. And it'll actually, you can hover over, it'll show you the pixels, what their colors are. And wherever you click, it'll have the hex code RGB right here. So sometimes it's like you want the font of your school's logo. Well, go to your school webpage and you can upload that image or use this extension to find the exact color and make that your font. The sports team colors is here. So this is where I got all my different golds. And then I'm sharing with you the template for this activity. The last part of this, and you're welcome to slide. Offer in case people are curious of how I created this, because this is what I want for. Yes, I wanted you to learn hex, but I wanted you to kind of say, hey, is this something I could use in my classroom? Is this something I could use, as a learning tool? And it's pretty basic, like a Google slides up here. You can add a new slide, populate it with components on this over here. And then you can get pretty sophisticated after that. I wanted to point out some of the things like that multiple choice question had a response I could give students. And so here's where you can kind of see there's some pretty specific coding that can be used, and it's not really any particular language. It's Desmos coding, but you can see it's logic, kind of an if submitted, and you've selected answer 3, respond with correct. So I don't expect you to learn this right now, but I'm offering you, Desmos can be, it's sophisticated to where you can really specify responses to the students. You can specify how data is gathered. Here, that histogram, the histogram was gathering data from a question I called George prior slide. And you may think, okay, this looks pretty wild. I copied and pasted this from another teacher's slideshow because guess what? It's open source. So you can see behind the scenes for all these slideshows, if it's something that's been done in another slideshow, but I've given you that as a link here in case you want to use this, learn from it, take this activity and use it in your classroom. I know hex coding can get students, so I thought making a color scheme as a starting point might be helpful. So any other Desmos users out there? All right, good. So if you're just joining, we're on a Desmos. Put the link in the chat. Yeah, so I'm telling you, there's a lot of pre-made Desmos. Now, if you're a math teacher, you're in heaven. CS content, not so much. But I think it's easy to create engaging lessons that you don't need a coding terminal. Maybe you're in a conceptual type of subject. And so this is a great way. Oh, you have a ton? Okay. Well, I know I'm doing this. I'm just doing a quick search. So in Desmos, there's a lot of public like activities, and they've created a lot. So again, I kind of select the big pictures. Desmos is open source, meaning it's free, but there's no like premium level. You are in the premium from the start, and you can see behind the scenes on other people's activities and see how they're coding them up. So, oh wow, with Java, okay. Well, touch base, Laura. I am interested in expanding my library. So there are custom ones, but then there's also activities you can search for. So I don't even know if I could type in computer science, AP computer science. Oh, that's me. Huh. All right. So anyways, I haven't found a way to search live for a lot of Desmos activities. So maybe that's something we'll work towards getting as a library specific for computer science teachers. Well, that's really all. Did anyone want to look through? So I thought it would be fun is if here I've given you the template, go ahead and try to add something. Maybe the first is to add a slide. You can just add a note. And these activities I was doing were mostly comprised of multiple choice. Let's say you can give them a multiple choice, and actually if you want to convert it to check boxes, you can. So there's a lot of what I like about it is you can get students engaged and you can see them live. So we'll go back to the live session here. And these codes don't really expire. I just really like how, the open source keeps it sort of, out there, and you can make it secure so only students from the Google Classroom can join. And their responses are saved. There's no going back and trying to fish out old responses. So, my goal today was just to introduce you to it. If you feel like this is something you'd like to use, I was introduced through I put my email in the chat, but I was introduced to it through a math class curriculum. It's very math oriented, but I think when it comes to getting feedback, even a quiz, you could do a quiz on Desmos, and students' responses, you can see their work. So I think this is a great tool for anything virtual. And if you'd like to chat class, please do so. And if you want to leave me feedback in the chat, I know I've asked you on slide 14 just to see where you're at. So I want you to drag this point to where you are with, I know I did a hex pixels, but maybe just Desmos. So again, my email's in the chat. It was a pleasure having you in the session. Thank you so much for your engagement. And the next thing is a 5-minute break. So enjoy the rest of the CS Ed week. Getting ready, hop in. Thank you, everyone. My pleasure.